Multiplying radicals, the overall general rule is right there at the top. And actually, while I'm at it and thinking of it, I'm going to add a flashcard on this. And the front of your flashcard is going to say a square root x times b square root y. And I'm keeping both of these a square root. In order to multiply, they both have to be the same root. Okay? So I use nth root on your sheet, but here I'm just going to, your flashcard is just going to apply to the square root. And the rule is very simple. Your coefficients, a times b, get multiplied together to be the new coefficient. And since they're kind of the same radical, they get multiplied together. Root x times root y becomes root xy. It's a very simple rule. Multiplying is much easier than adding and subtracting because we don't need them to be like radicals. The x and the y can be different numbers. They just multiply to give you what's underneath the radical. Okay? So that I'm going to add as a flashcard. Here at the top then, your coefficients just based on the generic way this one is written are a and x. So a times x is going to be the coefficient. And then it's an nth root, so we're going to keep that. And then b times y. So I just kind of switched up what variables were where, but that's the idea. Okay? Now, 99% of the time, and when the 1% of the time comes up where you wouldn't do it in this order, I will tell you. But 99% of the time, I would suggest you multiply first and then simplify. Okay? Because if you simplify first and then multiply, a lot of times you're just going to have to simplify again. Okay? But you could do these technically in either order. You could simplify first and then multiply. But like take this first one for example. If you tried to simplify first anyway, 10 doesn't break down to anything useful. 10 does break down to 2 times 5. But 2 times 5 is not helpful because does anybody in here know the square root of 2? Or know the square root of 5? No. So you don't, yes, you can break down 10, but it's not into anything useful, so you wouldn't be able to break it down. So we're going to multiply first. Root 10x times root 8x is root 80x squared. So multiply first, then simplify. So now, how can I break down 80 into something useful? What times what? Looking for something that's a perfect square that goes into 80. Micah? 16 times 5. Root 16, root 5. How about x squared? Do I need to break that down? No. It will simplify. I just don't need to split it up. And then of that, I've got the root 16 and the root x squared. Root 16 gives me 4. Root x squared gives me x. And then I just have a root 5. Multiply first, then simplify. Number 2. They're both cubed roots, so we're all good. 5 and 2 are the coefficients, so 5 times 2 is 10. Cubed root of 6 times 12 is 72. And now simplify, but we're doing cubed roots. So what perfect cube goes into 72? Haley? 36 is a perfect square that goes into 72, which would be helpful if I was taking the square root. But I'm taking the cubed root, so I need a perfect cube. Cameron? 8. 8 times what? Right, cubed root 8, cubed root 9. So the cubed root of 8 is the same thing as what whole number, Mason? Cubed root of 8 is the same as what whole number? Cubed root of 8 equals what multiplies by itself 3 times to get you 8? Pick a number. Pick a number between 1 and 10. 2. Is 2 times 2 times 2 8? Lucky guess. Lucky guess. 2 times 2 times 2 gives you 8, so the cubed root of 8 is 2. We all know what the cubed root means. It means what multiplies by itself 3 times to give us that number, versus the square root of a number is what multiplies by itself 2 times to get you that number. Not what multiplies by 2 to get you the number, not what multiplies by 3 to get you the number. It's what multiplies by itself 3 times to get you that number. And it is 2. So 10 times 2 is 20. And then the cubed root of 9 you're stuck with. Were you going ahead, Mason? What were you doing? Like when I initially asked the question and you said, what? And I had to repeat the initial question. But you weren't working along the notes with me. You were obviously, you were? You acted like you didn't hear my question. Okay. All right, we're done. 8 root 7 times 4. 4 is technically a coefficient, right? It's not underneath the radical. 8 times 4 is 32, so we get 32 root 7. So if one of them has a radical and the other one doesn't, you just keep the radical that the one has, because this is technically maybe times root 1, you could think of it as. Right? Okay, so that is a way of thinking of it, but you don't need that. So 8 root 7s times 4 is just 32 root 7. Distributing is a thing, right? You see a monomial times a binomial, distribute. So you got to take it piece by piece. 8 root 3 times 5 root 6. Nate, what is that? Perfect. And 8 root 3 times 2 root 3. Nathan Henry. Perfect. So there's our multiplying first, then simplify. Can I break down 18? If so, how? Kaylee McAdam, what do you think? You can't. So no perfect square goes into 18? You can. Aiden, what perfect square goes into 18? 9. Good. 40 root 9 root 2. The root 9 is the same thing as 3. 40 times 3 is 120 root 2. Perfect. And then this one's interesting because how do you break down root 9? Right, you don't, when I say break down, I mean into what times what. You don't break it down because it's already a perfect square. So we'll just circle it and simplify it. That's 3 times the 16 is plus 48. So our answer is 120 root 2 plus 48. I can't add them because I don't have like, what? Like roots or like radicals, correct. There's a radical 2 term and then a constant term. So they're not like terms, so I cannot add them. Does that make sense? Okay. Number 5, more multiplying. When I initially multiply these radicals, Isaiah, what do I get? X times x cubed bumps you up to x to the 4th. Okay? How, if at all, do I break down the 18, Kirsten? Root 9, root 2. How, if at all, do I break down the x to the 4th? Jordan? Right, I don't break it down. I will simplify it, but I don't break it down into something times something else. I'm going to leave it as root x to the 4th for the moment because all I need is that exponent to be divisible by 2, and it already is. Now I'm going to simplify it. That will become a 3. This will become my x squared, and I have a root 2. So just when I'm questioning, if I say how do I break it down, I'm looking for into something times something. If it doesn't need to be broken down, just say it doesn't need to be broken down, but it will be simplified. Okie doke. Number 6 here, going with 4th roots. So take a second, try to think of what that's going to be when you initially multiply. and then I'll randomly pick on someone. McKenna, what do you think? Okay. 48x to the 6th power you told me to write. Is that what you have? Oh, with the 2 in the front. Is that what you have? Where's your radical sign? Okay, so yours does not look like that, correct? Yours is 2 4th root of, I wouldn't just say radical if you're reading that to someone, because it's not just a plain old radical. Radical means square root. So the way we would say this is 2 times the 4th root of 48x to the 6th. Yes? Anybody disagree? Perfect. Okay? Then we want to simplify. So it's a 4th root. How do we break down 48? Connor, what do you think? Perfect 4th power that goes into 48. First of all, what are the perfect 4th powers? What is 2 times 2 times 2 times 2? Take a minute to think that through. This is one time in math where I still count on my fingers. 2 times 2 is 4, times another 2 is, times another 2 is 16. So 16 is a perfect 4th power. Let's do our 3s. 3 times 3 is, times 3 is, times 3 is, that's tougher. 27 times 3 is 81. You got to get used to 81 being a perfect 4th power. And that's really the end of the list I had you come up with. Just do either of those go into 48 evenly? 16 does 3 times. So the 2 is there. 48 is going to be broken down to the 4th root of 16 times the 4th root of 3. And how am I going to break down, if at all, x to the 6th? Kaylee Smith. X to the 4th and x to the 2nd. Perfect. Because if we're taking the 4th root, we want the exponent to be divisible by 4, right? Okay? So the 2 times the 4th root of 16, and the 4th root of 16 is 2, so 2 times 2 gives us 4. The 4th root of x to the 4th is x, so that takes care of this, this, and this. And then the 3 and the x squared are trapped under the radical. Any questions on that? Nope? Okay. So here's a great question for us. We're giving you the answer. What would this have been underneath the radical prior to taking the cubed root? So take a minute to think sort of backwards about what would have needed to be under the radical to have made this your final answer. So you're almost thinking about taking this that got, this obviously this 2 got taken out in front. What would it have been underneath the radical that would have allowed us to take it out in front? So take a minute on your own. I want to see if anyone can come up with this answer. What should this entire thing be underneath the radical that would have simplified this? And if you get it right, I will give you a few bonus points on a quiz. But I want to give you a minute or two to think about it on your own, and then if you think you have it, I'll come around and check. 2 of you, 3 of you, 4 of you. Oh, this is awesome. No cheating. Very impressed. A lot more of you got it than my class yesterday did, because we actually did this example yesterday in the other class. So 2 claps for that. Or was that 3? 3 claps. Okay. The answer was 40, m to the 4th, n to the 8th. Raise your hand if you got that right. Nice job. Yeah, so I gave you all 3 bonus ones. So if we think backwards, okay, the cubed root of what would have caused us to bring a 2 out in front? 8. So there must have been an additional 8 under there. The cubed root of what would have caused us to take an m out in front? M to the 3rd, right? If it was the cubed root of m to the 3rd, we would have taken out an m. The cubed root of what would have caused us to take out an n to the 2nd? N to the 6th, right? The cubed root of n to the 6th. 6 divides by 3. Yes, you may. 6 divides by 3 to give you 2, right? And hence the n squared. So once you kind of put those back under, 5 times 8 is 40. M times m cubed is m to the 4th. And n squared times n to the 6th is n to the 8th. Now raise your hand if you understand that. Hopefully the same people that got it right, and then a few more. Okay? Micah, you didn't raise your hand. Why not? That doesn't make sense?
No, I did.
Oh, you do. Just yeah. That's a lot of effort. There you go. All right. So just a good brainstorming activity to really make you think backwards to understand this process inside and out. Okay? All right, we flip over. Another great question. Let's try it with this one again. On your own, take a minute, try to simplify this in terms of n, right? We don't know what root we're taking, it's just the nth root. So think this through and simplify that. my MVP here. Good job. Shoot, I should have flipped around the number of points I gave for each one. But all right, so the nth root of 3 we can't do anything with. The n, so let's do this actually. I'm going to break it all up to kind of show you. And the nth root of y to the n plus 3. So broken up like this, immediately I know the nth root of 2 to the nth power is what? 2, right? If it was the square root of 2 squared, if it was the third root of 2 to the third, right? We want the root number to match the exponent so that it can divide out and then just be what it is. So the nth root of 2 to the n is 2. Can't do anything with this one yet. This one, when we're dealing with a variable, we want the exponent to be divisible by that. Is 2n divisible by n? Yes, it goes in how many times? Twice. So I can take out x squared because of that, and a lot of you got that portion right. This was the piece that got us, okay? Let me ask you this. If it was the fifth root of y to the 5 plus 3, that would technically be the fifth root of y to the 8th, yes? And how would you break this down? You would break it down into the fifth root of y to the 5th times the fifth root of y to the 3rd. So that this you could take out as y, and then you would have 3 left over, right? So you would break this down into y to the nth times y to the 3rd. The nth root of both of those. Does that make sense? The nth root of y to the nth we can take out as y, but then the nth root of y to the 3rd is stuck underneath. So the 2 remaining are the 3 and the y to the 3rd, and that should be your answer. So this piece right here really requires the exponent rule of breaking up and adding the exponents. And once it's broken up, that one we can take the nth root of, that one we cannot. Does that make sense? Any questions on that? A technique that I did there that you should get used to doing, especially if you're in a pinch and you're not sure how to think about a problem, it can help shed light on the way that you're supposed to think about it. When you have something very generic like an nth root, it's hard to think that abstractly about what root you're taking, the third root, the fourth root, you're taking the nth root. Because it's hard to think that abstractly, give it a number and just play around with it and kind of see what happens, right? You could have given it a 6. You could have made it the sixth root of y to the 6 plus 3, and the same thing would have happened. You would have gotten the sixth root of y to the 9th, and then if you thought about how to break that down, you would have made it y to the 6th, y to the 3rd, the sixth root of both of those, and this always would have been your y, and you always would have been left over with y to the 3rd. Okay? Any questions on that? So it's just a good technique to be able to play around with. And then just a little more practice on adding and subtracting. So we have a sixth root, a fourth root, a sixth root, and a sixth root. Simplify first. First term we can't do anything. What's a perfect 4 that goes into 32? I'm going to go to Connor on this one because I know he's the new expert. What's a perfect 4 that goes into 32? 8 is a perfect cube. Remember the perfect 4s that we just worked on the front side, 16 and 81? Which of those numbers? 16. So the fourth root of 16 times the fourth root of 2. Now, sixth roots. We have not talked at all about sixth roots, have we? But just like we did earlier, we can come up with perfect 6s just by going through that process. Like I said, this is the one time I still count on my fingers. 2 times 2 is 4 times 2 is 16 times 2 is 32 times 2 is 64. So 64 has a sixth root of 2. do I dare go to the 3's? 3 times 3 is? Times 3 is? Times 3 is? Times 3 is? 240 something. No, I don't dare go to the 3's. So 64. Let's hope and pray. Does 64 go into 192? How many times? 6 root of 64 times the 6th root of 3. Minus 2 times, and then there's the 6th root of 192 again. 6th root of 64, 6th root of 3. All right. First term, nothing I can do. Plus the next term. What was the 4th root of 16? 2. Times the 2 that's already there is going to make that 4 times the 4th root of 2. On the next term, the 6th root of 64 we said was 2 times the 3 that's already there will give us minus 6 6th root of 3. And on our last term, the 6th root of 64 is 2 times the 2 that's already there will give us minus 4 6th root of 3. And what are like terms that we can now combine? 4 of these minus 6 of these minus 4 of these. Well, that's good because the 4 minus 4 just cancels. And then that's your final answer. Negative 6 6th root of 3. And then 4 times the 4th root of 2. If I were to rewrite that problem, I kind of wish I had made this the 4th root of 3, just to illustrate that the 4th root of 3 and the 6th root of 3 are not combinable because they're different roots. And the last one, the only thing we have to simplify is the 384. Andrew, did you have a question? Before simplifying? You could. Yes, you could. So he's saying, if you notice they're combinable early on, could you combine them there and then simplify? Absolutely. That's okay. So your homework is coming out. You have a quiz coming up on Friday on radicals.